Welcome to the pilot episode of the Sandbox Show, a show
a YouTube show.
Where we'll deep dive into subjects that developers find interesting.
Don't worry, there will be plenty of live coding.
I'm Shannon, and this is Richard, and we're going to cover a broad range of topics as the show evolves, but for today, what are we going to be covering?
On this first episode, we're going to be covering idempotency. We had talked to people in our community, and the thing that people seem to be really confused by is this concept of idempotency and how does it relate to interacting with an API.
Right.
And so I didn't do some Googling on this beforehand, but I know that you did.
I did. So the definition of idempotency comes from idem and potent. So idem being same and potent, power or potency. So it's the same potency. This was something that a man named Benjamin Pierce came up with in 1870. So the word has been around for a while, but more recently in 2000, Roy Thomas Fielding mentioned it in his thesis. And that's really where the modern use of the word is coming from. So his thesis I have pulled up here is the architectural styles and the design of network-based software architecture. So that really gets us into the HTTP verbs and was where the HTTP 1.1 spec came from.
Yeah, and so that's kind of traditionally how I've just learned to understand idempotency and trying to understand how different verbs behave when they're implemented according to spec.
So what's a verb?
So a verb is in the HTTP 1.1 is you have all of these different options where it's you have a post verb, a get verb, and these are really just kind of saying what you're wanting to do with a particular resource at an endpoint.
Absolutely. I think of it as kind of related to CRUD, where the verbs are going to be expressing this create, read, update, delete, and other things, but you get some network behavior that makes sense with these actions.
Right, and so you should have this understanding of if I'm doing a GET request, I shouldn't be sending any data to a server beyond I'm making a request at this particular endpoint, and then I should be getting whatever I want back.
So is a get verb idempotent?
It is, and it's also considered to be safe, which is another thing that we'll sort of dig into, because safety is kind of determining whether or not you're changing something on the server.
Absolutely. I think that's an easier concept to understand, because you're simply saying, if it's safe, then my request, a GET request, is guaranteed to not make a change on the server. The spec is saying, I'm not changing the server here. I'm asking for a response, but I won't be modifying data.
Right, and so there's other endpoints like head or options, used a little bit less commonly, but are still completely safe because they're not changing anything. They're just getting information from the server.
Right, so a head is
you can do.
like a GET request without the body. And so again, you're guaranteeing you're not adding a record, you're just refetching a resource.
And so some other verbs that aren't considered to be idempotent would be the post. That's universally understood. A post is generally not idempotent.
Right. So, and a post isn't safe either. So a post is by nature creating a new record. So it's the create of CRUD.
Exactly.
So so post is neither safe nor idempotent. What's something that is not safe but is idempotent?
So delete is supposed to be idempotent because the requests should stay the same, but it is actually modifying a resource on the server. So I can run the delete request. I should get a 201 response indicating that the action has been taken. But in successive requests, I might actually get a 404 saying hey, this record isn't found anymore.
Right. And so the idempotent nature of delete there is that you can try the delete multiple times. If you don't know if it happened the first time, you can try it a second time, and the result is going to be the same whether you did it on the first time and the second, or whether you just did it on the second. In either case, you've just deleted a record. So it's not safe. A change has happened. But it is idempotent, because that change is going to be the same no matter how many times it's been done.
Exactly. And so that kind of touches on one of the main takeaways of idempotency is that you want to have this action only be taken once.
Right.
No matter how many times I make my request, if it's idempotent, it should actually only be doing that action once.
And so patch is an interesting edge case. We don't see patch as often as post or put, but post not being idempotent, meaning that if you send it twice, you're going to get a different result. You're going to have two things instead of one.
Right.
Put, you're going to only end up with one. Patch is one of those ones where there's no idempotency guarantee, but it's not idempotent in nature because you could be patch is like a put, but for part of the record.
Right.
But the reason that it's not idempotent and put is because you could be doing something like, say, adding a bicycle to Richard. It's you get a new bicycle, but that's maybe a patch to your record, as opposed to replacing them, which you could do it twice and it would be the same. If you added it twice, it could be, you'd have two.
Exactly.
So I think we've are sort of focusing in on something that's fundamental about idempotency is that we're trying to make sure something happened once.
Right. And so that kind of goes into why are we talking about this, and why are developers needing to understand this concept when interacting with our APIs.
Yeah.
And part of that is because there's certain endpoints that we have where we want to be able to create a resource. So a post is the most suitable verb.
Right.
But we still want it to be idempotent. But post is inherently not idempotent. So how do we actually circumvent that?
An idempotency key. So with a put request, we'd have an idempotency guarantee, but it's not. We don't have an existing record we're trying to overwrite. We're trying to create a brand new one. And so
Right.
post is really the thing we want to do. And your browser is maybe going to warn you if you retry, but we want to let developers get idempotency with a verb that is otherwise not idempotent. Meaning, we want to let you ensure that you're only doing this thing once, even if the underlying
Right.
network architecture doesn't guarantee that.
So I guess it's why would we want to have that kind of guarantee? My assumption is I make a request, I'm going to get a response. I'm sort of envisioning an ideal world where everything works well.
And I think that's a really good point, that if you always got back a result for your request, you get back a response, and that was a guarantee, we would not need idempotency keys. In fact,
Right.
we wouldn't even need REST because there would be no need for caching or the replaying of responses. With REST, you can have a put request and the network can simply be I don't know if it got through, just do it again.
Right.
And so it'll automatically assist in these things. Or it's cacheable because we know that the GET request doesn't modify anything, so that a subsequent GET request can just grab the response that was cached in an intermediary server.
Exactly. So the main issue is there is this uncertainty that's always going to exist with these systems.
Absolutely.
And so I might make a request and say hey, I want to create an order, but maybe the service I'm requesting is down.
Yeah.
Or it's I'm getting a 500 error, or maybe my service goes down. I make the request and then my service goes down, but I haven't gotten the response yet.
Absolutely. So you see all sorts of points of failure because it's a real world and we have networking. And so,
Right.
yeah, you were saying, you send the request out, and at that point, if you don't get the response back, you don't know where it went wrong.
Exactly. And you don't want to double charge or create duplicate orders.
Exactly. It may have gone to Square's server and just we messed up. It didn't come back. Or
Yeah.
it may have gone to Square's server and your service was momentarily down and it did come back. Or it might have gotten waylaid in traffic. So you don't know, did it make it to the server and succeed and I just never heard about it? Or did it never make it to the server?
Right. Yeah. And so, it sounds like you had mentioned this earlier. Idempotency key is
Yes.
the way that we do this. So what exactly is an idempotency key?
So I typically think of it as a UUID, a unique ID. But it doesn't have to be a UUID. UUIDs
Right.
are typically in a standard format with dashes in there and a pretty long thing for a guarantee of uniqueness. But you could also use a combination of timestamps and other relative information.
Right.
But I think a UUID...
And hashing that. You probably wouldn't want to just use a regular timestamp by itself because you might have too many requests within a short period, but you can use that in combination with something else and then hash
Absolutely. You need to make sure, if you're not going to use UUID, where the programming language is guaranteeing uniqueness,
Right.
that you are guaranteeing uniqueness. And so yeah, a timestamp, two users could have the same timestamp and
Right.
the action only happens once. Absolutely. That's a really good point.
Yeah. And so we really want to talk about so why this is relevant at Square.
Right.
Is we deal with things like creating charges, creating orders, and so in order to create that charge, it would be terrible if all of a sudden I made a request and then I retried the request and then I charged somebody's card twice.
Absolutely. And likewise, you don't want to not charge their card and just be
Right.
we're just trusting that these charges go through. So you want to make sure I can retry this, but it won't happen more than once, no matter how many times I retry.
Exactly.
And typically, you're going to only retry until you get a response back. So the
Right.
idempotency key is there to be a point of truth that this won't happen more than once until you get that successful response over the network.
Exactly. And so part of why we want to continue on this is we've recently released some SDKs, both in Ruby and Python, and we have more to come.
Absolutely.
But you had helped design the Ruby SDK and how that implementation works, and we actually baked some of that into the SDK.
Yeah, absolutely. So if you're using the API directly, it's up to you to decide how many times you want to retry, and also some interesting other things like how long should an attempt go until it times out. Like we have a default of 60 seconds, but maybe you don't want to wait 60 seconds. Maybe you have a service that times out after 20 seconds.
Yeah, maybe your platform only allows like a 30-second timeout window to wait for a response.
Exactly. And then also we have the intervals, like after you've timed out, how long do you want to wait? And the default, I think, is 0, but how long do you want to wait before you try again? So the idea is if you're waiting a whole minute, then you might as well try again immediately. Also, the default amount of retries is 0, so it's going to not retry. But you can instantiate a client with 3 retries, 10 retries, a timeout of 10 seconds, an interval of 1 second. But this can lead to problems because let's say we have a ton of requests. We've just opened for the season, we've sold 1,000 items. And it's on the default, and we change it so we have some retries. We remove exponential backoff. What we're going to see is after maybe a 10-second timeout, all 1,000 will try again at once.
And then you end up with this like stampeding set of requests coming to a service, and you could end up in like causing the service that you're making those requests on. Maybe they're having their own downtime, and part of that downtime is actually being caused by the stampede of requests that keep coming in.
Yeah, so you get
so exponential backoff is a way that you can actually be kind to another service to sort of say like, hey, we're going to like dial back how many requests we're making, and then like as things start to recover, things can start picking up speed again.
Absolutely. So you don't want all 1,000 requests landing, and then 10 seconds later, all 1,000 requests landing, and maybe like 300 get through. So like instead, they can start staggering.
Right, and an exponential backoff kind of like allows like a spacing that kind of increases very rapidly if you're doing it way too successive.
Absolutely, and you can change that curve to match. So it could go from 1 to 100 to 1,000, but it could also be a lesser curve, exponential curve.
Right. And so I think this is probably a good time that we can actually just start showing the Ruby SDK.
Absolutely.
Get a little bit hands-on with it, and then after that we can try to dig into like building an app with the Ruby SDK.
Okay, to the live coding.
Great.
So I'm going to then just first install the Ruby SDK. So it's called square.rb. So we'll just gem install square.rb. And that'll install the gem locally for testing. That's enough for like using it in the REPL. If you want to add it to a project, you'd of course add it to your gem file. You add a gem directives like gem square.rb. And that way, when you bundle, it will resolve the dependencies, so square.rb.
Right, and one of the other benefits is that in those instances, you can it'll be pinned to a specific version because we do actually have the versions of our SDKs matched up with the versions of our API. And so that you want to make sure that if you're creating something that's going to be consumed by other people, that they actually can see in your gem spec, oh, they're using this particular version of the Ruby SDK.
Absolutely, and also when you bundle, it'll create a gemfile.lock that you should check into your repo because that way all the other developers are using the exact same version of the SDK and locked to the same version.
Hopefully fix it only works on my machine.
Absolutely. Okay, so now that we've installed the gem, let's jump into a Ruby REPL. I'll use pry, and we can just require square to get access to the gem, and
so I think at this point, you should probably initialize the client.
Yes.
And so that's going to require getting your access token, setting an environment. So the main place where you're going to get your access token for a Square developer account is you go to developer.squareup.com/apps, and then you can actually find all of the prompts there for actually creating an application, getting your app ID, getting your access token.
And make sure that you select the sandbox mode when you're clicked in under your application. Go over to sandbox mode to grab the access token because we're going to want to be playing with this in sandbox mode and not making real charges.
And it's worth mentioning here, your access token, whether it's sandbox or production, is private.
Yes.
You should not share it with other people. You should not publish it to a public repo. It's intended to give access to your account. And so you shouldn't allow other people to have it.
And that means that you should not be putting it in your JavaScript. If it goes on the front end, they can just look through that code and find it. You should not be putting it in your mobile apps. They can disassemble those binaries and get at your access code. And that is not something you want to leak. Even keep the sandbox one secret. So I'll go ahead. I have an environment variable set up with my sandbox token. I just have it called Square token, but it is a sandbox token.
And this might be how most people do it in like a service that they've deployed, but they might also use like a key management system to read that in.
And then to be sure, I've made this mistake before, that I'm going to be using my sandbox token, and this isn't accidentally a production token. I'm going to also set my environment to sandbox. And so this is good because if we accidentally put a production token in here, we would get an error.
Yeah, exactly. Yeah. The request should fail if you're using the incorrect token for the incorrect environment. The other thing that it's worth mentioning is that the reason we want to set the environment is that it's going to target different endpoints.
Yes.
So for our sandbox, we actually have a separate URL that you would actually be targeting. And that's part of how we can control to make sure that you're not putting test stuff into your production account and production stuff into your test account.
So I'm going to go ahead and enter since we have this set up, and this will instantiate a client. And then we can actually see in the output here things like max retries and max interval and timeout. And you can set those as keywords when you instantiate your client.
Great.
So actually, let me go ahead and do one of those now because I want to set the max retries to more than 1. So let's set max retries to 3. OK, so we have a new client. So what should we do with it?
Let's try to just pick an endpoint that's both idempotent and safe, and it'll actually return data if you haven't actually seeded any data in your account. So list locations is probably like the most common one you would start off with. OK,
so I'll do client and then tab complete for locations and then list locations. And does that take arguments?
No parameters. Should just return back some data.
OK, great. And so we did this right. We got a 200. So let's go ahead and just look at the data that we got back there. We see I have like my one default sandbox location. It looks like I haven't created others.
So we should probably just try out an idempotent endpoint. There's a couple to choose from. There's like payments, there's orders. I think payments would probably be the most straightforward for us.
OK, great. So I'm going to go ahead then and do client.payments. You can just, again, autocomplete to get at that API. And what are we going to do? Let's see.
Let's do the create payment endpoint.
OK, so we'll do create payment endpoint. And this does take an argument.
So that'd be like a body.
And then we need to pass it.
Oh, before we do this, we probably want to actually set an idempotency key.
OK. So I'm going to, I can do it inline. Let's see. Well, it depends. What do we want to use for an idempotency key?
I think, we could use a UUID.
Okay,
so I think secure random is the primary library to be using that for.
So this is already included because Pry was using it under the hood. But other languages like Python, .NET, Node, Java all have UUIDs. They just look at the documentation.
And it's worth noting here, to try to use a library for generating a UUID, don't try to generate UUIDs yourself because there is quite a bit of math involved, and you want to make sure that you don't get a collision and accidentally have a payment fail just because you decided to implement UUIDs yourself.
Yeah, so the great thing here is if we create a million UUIDs, there's going to be no collisions. They're all going to be unique, and that's what we're getting a guarantee from the programming language. So don't write your own algorithm if you want something unique.
Exactly, and the great thing about a UUID is because it's going to be unique, it's also something that's safe to put into your logs to easily find where something happened.
So I've shown here, I've created one UUID and set the local variable UUID to 1. So we have this 9A6 UUID. Yeah. So we're not creating a new one for each. We're just going to set this one UUID as the idempotency key. So let's go back to the client.payments.createPayments. And in the body, we'll add idempotency key and set that to the UUID.
Perfect.
So
then I think the next key that you need is amount money. So we need to know how much we're going to be charging.
And I remember that takes
and it's its own object.
Amount.
Exactly.
And this will be in the lowest denomination, so cents if we use US dollars. So let's do $1. And then is it currency? OK, perfect. And then that is it for our amount money. And then the last thing we need to pass is our card token.
That's right.
So let's do a source ID, and we don't have a card token.
Right. So what we want to use, since we're in sandbox mode, there's a couple different ways that you can actually get a card token. We have a standard card token that you can use. That would just be like cnon : card-nonce-OK.
Card-nonce-OK.
And then we can also generate our nonces. If we had the sandbox payment form loaded somewhere, we can enter card data. There's a couple of card numbers that you can use that you can find in our documentation. But you can type those in, and then it'll generate different nonces every single time.
I find those super helpful. So you can, in the card entry, you can put in particular card numbers and information to get a nonce back, but you can also use pre-done nonces like this one we're grabbing here.
Right.
This one's OK, but we could simulate a CVV or a postal code.
And so why is it that we actually have to use a nonce? for this?
Well, so when you have a payment form, whether it be on a web browser or in a mobile app, you're going to have direct communication between that form and Square servers. And that data is going to just be directly encrypted onto Square servers.
Right.
Your form is going to, instead of giving you back this private information, it's going to give you back a nonce, which is a card token that you can either send to the payments API and make a charge, or you can save on file as a card ID with the customer's API.
Right, and so it's a single-use token as well, so you
Absolutely.
can't use it more than once.
Yeah, you can almost say it's idempotent. No, it's
Yeah.
not. So yeah, a nonce just means single use. Nonce word is a word that's only used once, and this is a card token that can only be used once.
Right.
So
And it's also worth mentioning that they only last for a certain amount of time, so you want to make sure that you use them right away. You're not supposed to be storing these somewhere and using them later.
And if you do want to store them as a card ID in the customer's API, and then you can use them repeatedly.
Exactly.
You just need to get permission or notify your user.
Yeah.
Okay, so let's go ahead and hit enter and see what this does. So I've saved it to local variable response. It is a 404. So that was not what we wanted. Card nonce not found.
Let's see what we did.
So we can check the response errors.
And you know what? It looks like we actually spelled out okay for our test nonce. So let's go ahead and just remove the AY at the end there. And then we can actually get that to work.
Okay, so with the just
Great.
okay, it's not OKAY, it's just okay. Okay, so that was successful, so we get back the 200, and we can now see that this was a success. Yes,
Perfect.
And we can get our data. Awesome.
And so now we know that the payment has gone through once. What do we think is going to happen if we run this again with the same exact idempotency key?
So interestingly, it could have retried. Like it didn't here because it was successful the first time, but internally, like we set it to retries 3. So even if this retried internally, we didn't create more than one. And if we explicitly run it again, we can look here at the response back and we see that the ID of this payment is 8TJT. So let's try doing a new one.
Yeah, let's just run it one more time.
So this would, if we didn't have this idempotency key here, or if we set it to something new, this would be a brand new charge. So I'm going to hit it, and then let's look back at the response, and we see it is the exact same payment. So this isn't a second payment. This is the first payment.
Exactly. So Square has actually replayed the response back to us because maybe we didn't actually receive the first one, so we now know this has actually been successful. Another hint, say that you actually didn't receive that first response, so you can't match the IDs.
Yes.
You can actually just get hints from like the created at and updated at fields and look at the timestamp and see, is this in the past?
That is a
or
good
is
hint.
this like closer to when I actually made the request?
Yeah, I like to parse the timestamp and then just subtract the current time. And then you end
and then
up
you
with
can
like,
know what is the lag.
yeah, this charge was 10 minutes ago. So it's not just happened, it did go through earlier,
Right.
and you can confirm that in your dashboard.
So we now see how this idempotency works when using the Ruby SDK.
Absolutely.
Why don't we actually just build a real app?
Okay.
I'm a little bit more comfortable building front ends. I know that you're comfortable building back ends. So why don't you just sort of scaffold out a back end, and then I can then switch over and build out our front end.
Okay, I'll just stick with Ruby rather than doing Python here. And instead of using Rails, because that's going to give us a lot of boilerplate.
Yeah, that seems like a bulky
I'll just
thing
use
to build out right now.
Rack or Sinatra or Rhoda directly. I'll just use Rhoda since that's my favorite.
Yeah.
So Rhoda is a minimalist framework on top of Rack. It just adds a routing tree, and some little niceties that we want here. Rack is the basic web server for Ruby. It's used in Rails and Sinatra and Rhoda, and you can use Rack directly. But so I'm going to go.
This allowed us to get us like just a very simple REST API.
Absolutely, and we here probably only need a couple routes if any. So let's. I guess first off, what should we call the project?
Let's just call it payments backend.
Okay, payments backend. So I'll create a directory, cd into that. And then for Rhoda, normally I would do a bit of a directory structure, but let's just do a config.ru. That's a common endpoint for all Rack apps. So we'll touch a config.ru. And then actually, I'm just going to jump into this in Xcode.
Perfect.
OK. So this is a brand new file, so we need to do some requires here.
Yeah, we need to bring in some components. So like maybe we want to require Rhoda.
Yes.
So we need Square, of course.
And
then we need to generate UUIDs, so we might need secure random.
Yes, and this won't be already required by Pry here since we're not in the REPL.
Right.
So let's add secure random. Okay, that should get us started. And then for a Rhoda app, there's a couple different ways you can do this, but I'm just going to do this inline in the config.ru. So I'll do class app inherits from Rhoda, and then capital R Rhoda. And then let's go ahead and do our routing tree. So Rhoda, you just define a route, do R by convention, and then we're ready to do our route. So at this point, we have a basic scaffold for a Rhoda app, and we need to decide what routes we want. And routes are comprised of both the path and the verb. So like, is this the root route and a GET request? Is it under, pay me now and a post?
And so maybe like touching on like in this block of code, when we're doing route do, we're basically continually like listening on a port, and then as requests come in, it'll repeatedly call this and like try to go through this loop. And then how does it actually match to a particular endpoint? Okay,
so like Sinatra previously in 1.0 actually like made for each one of the routes, they made a regex, and they would just run through all those regex. Rhoda is a response where there's a routing tree, so you don't have to go through every path. If you typed in, pay me now as the path, you can then check for the verbs in that part of the routing tree. Sinatra now uses a finite automata, and so does Rails, where you get that boot time penalty. But the routing tree is a really nice way for us to just lay out our app and say, if you're going to these paths, here are the associated verbs.
And then it'll just find the first matching path, and then
try
to match a particular method that you're requesting.
Exactly. So let's go ahead and decide what we want our path to do. So with Rhoda, you can do on to mean that this is not terminal. Like anything under here, continue to try to match, and is will be terminal.
Gotcha.
So let's do an on, and then what do we want the path to be? Root or something?
Let's make it like /pay. We're just going to do a basic payments endpoint.
So we'll do R on pay, and then do, and then
so rather than the root, we're actually going to like go to whatever our base URL is, and then we're going to do / on the path pay.
And since you said pay, I'm assuming you a post.
Yeah. I think it makes the most sense that we're going to be creating a payment, so we better be sending a payload and expect a payment to be made.
Okay, and then let's just...
So how do we actually get the data? So like if I'm sending a JSON blob over to your backend, how do I actually read that data from Rhoda?
I guess it depends on where that... Is the JSON a body?
Yeah,
okay,
it's going to just be in the body of the request.
So then we can just do r.body.read. That'll get us the raw body, and then we'll need to parse the JSON. So in the Square standard library, or not the Square standard, the Ruby standard library, there's a JSON. So we can just require JSON, and then we'll JSON.parse the body. And I like to, this is my personal preference, but I always like to symbolize names true. And what that does is the keys, it will turn them into symbols, because I just like to use symbols as hash keys in Ruby.
Perfect.
Okay.
And so then, is this just going to echo back the response? What are we going to send back to the client, in this case a web front end,
well,
we've made a request?
So this won't do it, because this is literally going to be a Ruby hash that is the parse JSON body that you sent me. So let's go ahead and, this is a little bit weird because we didn't have to parse it if we want to do this, but let's go ahead and parse it out and then turn it back into JSON, and I'll just echo it to you. Okay.
That's perfect.
Let's just say this is payload, and then that'll be a hash, a Ruby hash. And then we can just do payload to JSON. So this is, if you post to the pay route, this should return you like the JSON body that you posted me. It should just, like,
so it'll echo it back. So we'll at least know that the server's working and I'm communicating with your system.
Oh, and then one more thing I have to do, I often forget this, is to run the app.
Yes. Always remember to run your
app. The rack convention is that you have a config.ru, a rackup file. And then you call run, and you pass it something that responds to call with, and Rhoda does respond to call with the status code, and then the headers, and then the body.
While you get that running, I'm going to pull up Postman here.
Okay, and I'm going to...
And then we will grab your IP address.
So I'll type rack up, and we'll see. I'm running this locally, so you want to grab my IP address, so I'm going to run this on 0.0.0.0. So it's outside my machine. You can see it.
And what port is this running on?
9292. That's just the default here.
I have that correct here. So what I'll do is I'll then just create a JSON with Postman here. So we'll just get a basic body. And we'll just say we're going to send a nonce. And we're just going to send the basic fake card nonce for now.
Great. And this isn't really doing anything on the back end other than being like, OK, here's what you sent me.
Correct.
Okay.
So I'm going to go ahead and click send. and this is getting 404
I
because
see a GET request.
exactly. So we
And it's also
we
to
picked
the
the
root.
incorrect
Right.
method. So
And their incorrect path.
it's kind of nice that you see that Rhoda is seeing that we've made a request, but we don't find anything that matches that path and method.
Absolutely.
And so it's giving the correct HTTP response back.
Which is a nice thing that Rhoda adds on top of rack. Rack would have just been like, you didn't account for
yes,
this.
exactly. So let's go ahead and switch this over to a post, and then I will run it.
Okay.
And then I still get a 404 not found.
So in the
Interesting.
routing tree, you weren't under the pay path. And
Exactly.
so it was like, there are no posts defined 404.
All right, let's try this one more time. We will run a pay, and there we go. I
Yay.
actually see my full response back. So we see I sent a nonce, and I sent the cnon card dash nonce OK. So everything looks exactly how I sent it.
Okay, so we have an echo server.
Perfect. So now let's get something that actually does something. So it's probably a good point for me to actually scaffold out a front end here.
Okay.
I was thinking about, so to kind of explain like what a front end is here. Here I'm going to build a web front end, and we're just going to use a basic React app.
Great.
We'll pull in a couple components, and then what we'll do is we'll actually implement a payment form so that we can generate a bunch of different nonces to send to the backend.
And this is what we'd really do if we were going to be taking payments either on web or on native mobile.
Right,
Because
the in-app payments SDK behaves in a very similar manner.
absolutely.
So let's go ahead and I will go over to my terminal. And then I'm going to use npx. For anyone who's not familiar, npx is just another tool that you can use when you have Node installed. You get npm, and npx allows you to fetch CLI apps and then run them locally without having to actually install them, which is really nice.
Nice.
The other benefit is that I'm ensuring that I'm using the latest version of Create React App without having to like update my local dependencies.
Perfect.
So we're going to go ahead and name this payments front end. And then I'm going to go ahead and let that run for a little while. And so that's going to be installing a basic React app.
Okay.
One of the nice parts about React is with Create React App, we actually get like a hot loading server so that I can actually serve up everything locally, and then I can see it. And then as I make changes, it'll automatically reload and let me see what they look
So
like.
I have not included rack reload in this app, so remind me, I'm going to have to restart mine. I don't have that fanciness enabled.
Yeah. And so we'll wait a little bit longer for this to install. So one of the other packages that we're going to use is the Square React payment form.
Okay.
So that is actually a payment form that allows you to provide like a basic component and then a couple fields, and then all you have to do is like it'll help you with doing your own credit card payment form, digital wallets. So let's actually take a look now that it's done installing. We'll cd over. There we go. Now let's just open this up. Perfect. So here's what the basic app looks like. Let's make that a little bit more readable. So you'll see that you have this basic public folder. This is actually where you're just going to see your index HTML, and then React is actually just injected in there as a script, and then it attaches itself on a single div.
Great.
And so we will just open this up, and you see that we have our index.js. That's like the basic form where we're going to initialize everything in a React application.
Okay.
And then the bulk of our app is actually going to be in app.js. So we'll go ahead and close this out, and we can see here we have some basic parts here. So let's actually just open up my terminal and like get this local server running.
Nice. And while you do that, I'm going to go ahead and start pretending like we're going to actually make a payment on the back end.
Perfect. So I'm just firing up the server here. You can see it's going to request some network access, and it's opening it up in our browser. So we'll give that a second for it to load up, and then we can actually see that our React app is loaded here. So we can see that the logo is spinning. So let's go ahead and make some changes to it. We'll close out our terminal. So let's go ahead and just remove this logo. It's kind of distracting. And then we'll save it, and then we can switch over, and then we can see it's already been reloaded and it's gone. So let's also change this to make it a little bit brighter by going into the CSS here, and we'll change the color here to white. Perfect. Double check that that looks that way. Perfect. So the first thing that we want to do is we actually want to import, first, actually, we want to install the React Square payment form. Perfect. So we actually need to use npm to do this. So we will stop our server, and then npm install save React Square payment form. And so by using the -- save there, this will actually save it into my dependencies in package.json. Package.json works kind of like a gem spec file in which we can define all of the different packages that we want in our front end application.
Like a gem file, yeah, or gemfile.log.
Yeah.
Perfect.
And so we'll wait a little while for this to install because it takes quite a few other dependencies. In the meantime, we can take a look over at the documentation. So we need to see what it is that we're going to actually need to get the payment form initialized.
Okay.
So a couple things that we'll need, because this is our front end, it actually requires having our Sandbox application ID. So since I'm going to be communicating with your server where you already have your Square access token, I need to be sure that I'm using your application ID for this front end.
That's a good point, and I've already sent you that. So the application ID needs to match with the Sandbox application that the Sandbox access token came from, and then the environment also needs to be Sandbox. So a common thing we see is one of these things does not line up.
Right.
Confirm that you are on the right application. That is yes. Essential. It's got to be the right application. If you're in Sandbox, make sure you're in Sandbox mode for the application ID and also in Sandbox mode for the access token. And then for extra care, set your environment to Sandbox so you won't be accepting an accidental production token.
So we're still waiting for this to install. Where are we at with the road app?
Okay, so I went ahead and pulled some of the code that we had in Pry. I pulled out this client equals Square client part and just put a new line in it. I also swapped out the local variable for a constant client because we are inside of a class here.
You're not going to be swapping out tokens and stuff, so why not just
it's just
use
one client. We can reuse that client, save some overhead. And then I went ahead and then just added in this placeholder body hash, and I haven't done anything else, but I think we're ready to copy over the, instead of lowercase client dot payments, it'll now be the constant.
Right.
So we'll client dot payments dot create payment, and then this time it'll take the body that we're going to define above.
Great. So it looks like I have this installed here, so we can actually get back to building our React app. So let's go ahead and take a look at what it takes to build this payment form. So we've already installed. It seems that we can actually just import this, and then we actually get some default stylings for the form. So we don't actually have to style the form ourselves. And then let's actually just start inputting this component in here. So right above where we have this edit source app.js, let's go ahead and create a Square payment form. Thankfully, this is built in TypeScript, so we get some auto-completing in VS Code here. So I know that we actually need a prop here. So a prop is just a property that you can set on a component. Okay. Here we're going to add application ID. And we need to go ahead and grab that application ID that you sent me earlier. That's going to be the Sandbox application ID. You can always tell because it actually says Sandbox in it. So let's actually put that in there. Let's remove all these extra spaces. All right, so we have this here, and I hit save. Let's go ahead and take a look. Are we getting any errors here? Oh, we're not actually running it. So let's actually start running that again in our terminal. And then we'll just actually let that run in the background.
And while you did that, I went ahead and just filled in the body with the content and idempotency key. I'm setting it to the secure random.uuid. So I'm just doing a UUID here because we'll use the SDK's retries rather than manually retry.
That sounds like it makes a lot more sense.
If we were going to do manually retrying, we wouldn't create a new UUID each time. We would create one and use it manually in our retries.
Right. And so we have to remember, though, that this is going to be on every request that we're going to actually generate our UUID and then continually retry within that single request until we get a success.
Absolutely.
All right. So we see that our React app here is loaded, but we actually don't see the payment form yet. So we probably need to add in a couple of components here. So we can take a look at what components are we needing. So here we see at the bottom, we actually need these credit card input forms. So let's go ahead and import all of these. Just add that into the end. And so this gives us all of our credit card number imports, expiration date, postal code, CVV, and even a submit button. And in the interest of true programming, I'm just going to go ahead and copy paste something from the example to make sure that we can get this working. So we'll just go ahead and copy all of these buttons and fields, and then we will throw that into our Square payment form component. I will go ahead and set that to format the doc so that it looks nice. And then we're going to go ahead and save. So let's go take a look at what our form looks like.
And that's enough for you to get the reload, just saving.
All right, so we already know that we didn't pass in a particular prop. We're missing our card nonce response received method. So we need to actually implement this.
And that's a good sign whether you're on the in-app payments SDK or whether you're on the payment form. When you start getting to the callbacks that are unimplemented, you're on a happy path.
Right, so we know that we need to go ahead and implement that. So part of that, I'm going to actually refactor the basic Create React app, and we're going to turn this into a standard component instead of just a simple function component.
Perfect.
So let's go ahead and refactor that. Class app. And then we will extend react.component. So I happen to know we need that to say extends. And then I know that every component has to have a render method. So we're going to go ahead and just change this to render. And then it's going to just return the same component that it did before.
Great.
So we'll add this in there. And then we will format our doc again so it looks nice and formatted. So let's go ahead and save that, and let's see what we get. All right, so we're still getting the same error before, but we know that we've successfully refactored the component.
Okay.
We're not getting any other syntax errors. So let's go ahead and add in this method that they want. So we will add in a constructor. We'll pass in some props. And then we will then just add in super props so that it can properly inherit them. And then we will then initialize this function that we need. It is card nonce response received. And here I'm actually just binding the context of this function to this component so that we don't have to get confused about what this means. And then now we'll actually initialize this function. So it's probably worth taking a look in the example there. What are the parameters that we're expecting to get from this function? So maybe, yeah, let's go ahead and just go back to the documentation here. So we can already see that we're getting back these errors because we're missing, we need to change bind. All right. So we actually implemented this slightly wrong.
Where did it go wrong?
So let's take a look at, okay, so we successfully adjusted it. We just misspelled our variable there.
Always check that.
So we have the function, and we need to just take a peek at what do we expect the parameters to be passed into it. So we can hear that we have a card nonce response received here, and we expect the parameters errors, nonce, card data, and then buyer verification token.
Right.
So let's go ahead and just copy these over. We'll put these into our method. And then it probably would just make sense that we just log some of these out for now. We're not going to be sending these anywhere. So console.log, and then we'll do card data, and then we'll just go ahead and also log out the nonce. So now that we have this function, we know that we need to pass it into the payment form. So we see that we can just pass in this dot card nonce response received, and then we will save. So let's go ahead and take a look at the form. So we can see that now we have a payment form.
Awesome. That looks like a payment form.
Exactly. It's like already styled. It looks great. So I'm going to just open up Chrome DevTools to take a look so that we can see things being logged out here. Oh, and I'm now seeing some errors here, and I know exactly why that is. So we see some 401s here. I'm actually using a Sandbox application ID.
Okay.
So I need to actually specify on my component that I'm going to be in sandbox mode.
So this is another example where you align your environment with your application ID, with your token, like make sure. This is important. And while you did that, I went ahead and pulled out the example nonce for the source ID. So I'll be actually using your nonce rather than the hard-coded test one. And then I also added a .raw body to the create payments code we had before because I don't want to be returning JSON. We could have parsed out the data and then to-JSON'd it, but since there's a raw body on these new SDKs, just use that.
That sounds way easier. So I've added in sandbox equals true as a prop, so we've gone ahead and set that. I'm going to go over here, and now all of my errors are gone. So we see we're not getting a 401. So it looks like we might be safe to just start entering a test card number. So here's the test card number of 4 and it's just a bunch of ones that we use for sandbox. We can do 1122, and then we can just do random postal code and 123, and let's go ahead and click pay.
Okay.
Hey, looks like we actually have the card data showing up there where we can see like, is it a digital wallet? What's the brand? What's the last 4? And then we actually have our nonce.
Awesome.
So it seems like the only next step we really need to do is we need to send this nonce to your backend.
Absolutely. I got my little backend working. You got your front end working, but now you need to send me the nonce so I can send it to Square, and then I can get back the response from Square and send it to you.
Right. So let's go ahead and we're going to just change this function to be asynchronous.
Great.
And then I'm actually just going to use fetch to actually send a post request. So this is just using the fetch API that's available in all browsers.
Perfect.
And
it's
a lot easier to using than like doing the standard AJAX.
I agree. I like that for browser side, absolutely.
So let's go ahead and then do let request equal fetch.
And so to be clear, right here, what you're doing is making a post request to the backend where you're going to be passing me the nonce, which is the card token that corresponds with encrypted data on Square server.
Right.
Then I can, on the backend, take the access token and also usually the pricing point of truth. Just like you don't want to put your access token on your web browser JavaScript code so they can go in there and maybe modify the prices, you don't want to put it in your mobile application code either. Someone can modify the binary. So it's best to typically pass the IDs of the items being purchased, unless you only have one item and know what it is, but keep that purchasing point of truth on your backend, as well as use your backend to secure your access token. The application ID isn't actually confidential and can be on your web browser front end or on your native mobile front end. But the access token is absolutely secret.
All right. We're just going to we're actually building out URL, and then we need to actually set that to your URL. So I'm going to go ahead and grab that from Postman.
And so we're just doing this over the local network, but you would deploy your backend to the cloud.
Exactly, and you'd probably have your own host and domain that you would actually be pointing this to.
Absolutely.
So I'm going to go ahead and set this, and we're going to add in HTTP. And then I'm going to hit save.
Okay.
And let's go ahead and test this out.
Awesome. And so the fact that you've gotten a nonce back doesn't mean that this card is actually good. What it means is that you've gotten encrypted data to Square's server, and you're now passing me, the nonce, to the Rhoda backend.
And did we get a request?
I see nothing.
All right, so let's go ahead and start logging things out here.
Good idea. Print-based debugging.
It's my favorite way to debug.
It works. So that nonce that he's sending over to the backend, we're going to send it on to Square server and check if it's a valid card. Check that it's not expired, that the CVV is correct. What the form is doing is checking that the expiration date is in the future. So the form won't generate a nonce unless you get data that might be right. Once it might be right, the nonce is generated, that card token is passed to the backend where we can send it to Square servers with our access token.
And then process it.
And process it.
All right, so I see that I'm getting, we have URL.
Okay.
Interesting. Oh,
are you doing port 9292?
So I'm now realizing what is happening here.
Okay.
My local server from React is actually expecting that I would actually be making this request to my own server.
Right.
And so it's not proxying the request to your server. So I need to actually go in and change some things in my package.json.
Okay.
In fact, we'll quickly look up when we're doing create React app how to proxy a request.
Great.
It's actually a pretty common thing to run into when you're doing development, when you're trying to do a front end and a back end. And so we're just going to go ahead and look at how do we add this in. Looks like we just had to add this proxy to where we want our request to go to. And we just want to double check if we can do it for a specific path.
Perfect. And if you're running, like if I was running this on localhost, it would only be local to my machine. But since I'm running it on 0.0.0.0, Richard can access it. But
let's actually go back.
And then while you do that, I think I have completed my application, so I'm going to go ahead and remember to restart it.
All right.
Because I've changed a few things, like setting the retries to 3, and then I also used the real payload knots that you'll be sending me. We'll see if that works. And then also I'm returning the raw body for the JSON now, so in order to get those changes to go live, I've just quit my application, and I'm redoing rackup on 0000.
All right, so I've restarted my server because I've modified my package.json and have the proxy. I do need to actually reload that.
Absolutely.
Because this is really only going to hot reload my React app.
Perfect.
So you have your server running, right?
We both restarted?
All right, let's keep our fingers crossed that this actually makes a request to
Yes! I see a get.
Great. So we at least see the request going through, but we're not actually seeing a post request going through.
Yeah, I do see a get, but it's going to the pay path. So we've got the path portion looking good.
All right, so let's actually just quickly take a look at
that was a
our
404
headers here and the body. That's a readable stream, but we're not seeing our method.
And so the issue here is the verb. It's a get verb, which, as we covered, is safe, meaning that it's not going to create this payment. We need the same path, but a post verb. And then we will not get that 404 anymore, hopefully.
Well, I set the method as post here, so I'm not understanding exactly why that is. So I'm just going to actually take a look at the fetch API to make sure that I have that correct.
I'll do the same.
Because normally you would actually just configure this entire object. I would say this is my URL, this is my method.
And interestingly, there's one other thing that it's both a get verb, but also it's going to the path pay / and then it looks like a list with object, %20 object. It looks like the serialization didn't quite work right.
All right. Let's actually just refactor this so that I can actually put the URL first.
Great.
Then I will go ahead and remove this part and just have the method set there. So we will try this again. React app is reloading. Let's just enter some more test data.
And what we're doing today is passing the card token knots to the backend and then making a payment via Payments API.
Right.
But we could alternatively be using Customers API and saving this card token knots on file as a card ID. That would let us go ahead and charge it now, but it would also give us a card on file that we could charge later. So the steps for getting there are the same on your end. You would just be telling me to put it on file. We'd create a second route, and we could then say do an instant payment, or if the user agrees, we can put card on file so they can easily check out in the future.
All right, so I'm going to go ahead and click pay here.
Yes. 500.
All right, we got a 500 error.
So this is closer.
This is no longer on my end. Let's go ahead and figure out what's going on with the back end.
Perfect. So you've done a successful post to the pay path, which is excellent.
Great.
But my server has blown up. So unexpected token at object. It looks like the body is not
Okay, so let's serialize
JSON.
that. Right. So let's go ahead and so we have a nonce that I'm sending you, but I realize now that I need to actually do json.stringify.
Perfect.
In order to modify my data so that we actually have it. And we should maybe also say that we want to, in the headers, what the content type is.
Absolutely.
That might give a little bit of a hint to your backend.
And normally we would, yes, absolutely. That's part of the routing. And I almost forgot to do the JSON as well. So that's a good point is when you're going to be getting JSON and sending JSON, make sure that it is JSON. Make sure that you deserialize the incoming JSON and that you serialize your objects into JSON before you send them back.
Okay, so it looks like I've switched the content type, set it in the headers, I've stringified my JSON. Let's go ahead and try to run this one more time.
Perfect. And I don't need to restart, so we're good to go.
So I will do 11:22. And here, is this the moment of truth?
404. So now this is an options and not a post. So this is very unexpected. I did not expect the verb to change to options.
Interesting. And I also got a 429. Oh, that's from a different endpoint from our Sentry error.
Yeah, so this is now still the right path, but the verb switched from being post to being options. The options verb is seldom used and is not what we want here. It is safe.
So I'm actually getting an error here when it says access to fetch at that endpoint from the origin of localhost. That I'm actually getting a CORS policy block.
Ah.
So because I'm actually switching domains and making my request, I think that we're actually getting blocked.
I think that is what's happening, and so it's getting the options verb to get back server information.
Right, so is it possible for us to change in Rhoda whether or not an endpoint would be CORS safe? Or can we disable CORS policies?
So I actually am not using a plugin, Rhoda-side, that should be providing CORS protection.
Okay.
There is Rhoda is a routing tree that has a plugin system, and you can cherry pick the plugins that you need for your application. I'm really not sure why we're getting that here, but I think it's because we're going through the local network, and I haven't deployed this to a service. Should I deploy this to Amazon Lambda or Heroku, or do you want to try to debug the local network?
Well, let's just try to quickly debug the local network.
Okay, perfect.
See if maybe there's something I can disable on my side for CORS in the fetch.
Yeah, I think it's the React side complaining because I haven't enabled any of the security plugins that you normally. That's a good point with Rhoda. Always go through the plugins. It's a wonderful plugin system like the SQL gem, where the base Rhoda only has nice error handling and it has a routing tree, but nothing else on top of Rack. And that means that it's way more minimalist than Sinatra or Rails, and because it's doing less, it's faster. No code is fast code. But it does mean that you are going to need to compose the framework that you want by carefully looking through the plugins and choosing the ones that are appropriate to your application. So
here I see that we have an option for no CORS. So let's go ahead and try and just modify that and see if that fixes things for us.
And you wouldn't want to do this in development mode, but totally fine. I'm sorry, you would want to do it in development mode. Don't do it in production.
Yes, do not do it in production. So let's go ahead and save that and see if that fixes things for us. So I will go ahead and go back. This is already reloaded. Let's rapid fire that credit card in there. And let's actually hope that this works.
Fingers crossed. Yes!
Hey, we got a successful response.
Hey, post to pay 200. This was, that was a completely successful charge.
Great.
So this will show up in our Sandbox.
Yeah, so we've actually managed to send a token to our backend and create a payment. So this is essentially proving that we can get this to work.
And it would be very simple to use the customer's API to save a card on file as well here. We would definitely want to be passing IDs as well as the nonce, so we could pull up pricing information from the database. But absolutely, we did it.
Yeah, okay. This seems like a good place to stop. In this first episode, we covered a lot about idempotency. We looked at the definition, the history of the word, a thesis, some background on HTTP, and then we spiked out a front end and back end to really show how idempotency works in practice. So what's next? That's up to you. Please write in your ideas for future shows or just let us know what you think. We are looking forward to hearing from you.
Happy coding until next time.